Hi there, my name is David Spezia, and I'm a principal sales engineer with our high-tech telco and media division here at Snowflake. I want to thank you today for joining our session on Snowflake resource and cost optimizations. We're going to be looking at some low-hanging fruit like resource monitors, auto-suspending warehouses, and auto-resuming warehouses, as well as deep diving into other features that you can use here to optimize your cost and performance in Snowflake. Enough talk, let's go ahead and dive in and get started.
Thank you so much for joining me today for our session on resource and cost and performance optimizations in Snowflake. We're going to look at a lot today, so go ahead and buckle up. Just as a disclaimer here, I don't want you running this code in production necessarily. If you do, please run this on a test warehouse or a standalone warehouse. As well, you need privileges to the account admin role. Or if you don't have those elevated privileges to account admin, you need at least imported privileges on the Snowflake database with the account usage schema in order to run the queries I am going to be showing you here. First off, I just want to state that I've been very fortunate to travel the world to talk about data and all things data. It is ubiquitous, it is everywhere, and we only ever generate more of it all of the time with all of our smart devices, connected devices, all the streaming that we do. And more folks are choosing to analyze that data and transpose that data and transform that data into something useful and stream it into Snowflake to make sense of what their business is doing in near real time. And as they're doing that, we want to make sure that they're spending the correct levels on Snowflake, optimizing workloads, always looking at what can be fidgeted with or tuned to give you a great experience when using Snowflake. And these are the few things that I have seen in my last 3.5 years at Snowflake, working with some of our largest accounts all across the globe. So what we're going to look at today is kind of in general, how metering works. We're going to look at the resource and cost governance frameworks that are in place in Snowflake. We're going to show you the account usage schema 101. What's there? How can you use it? We'll look at the lowest hanging fruit in any Snowflake account. We'll look at how to copy objects locally from account usage into your own accounts. We're going to visualize some objects, perform some additional optimizations. We're going to set up resource monitors and even show you how to use Snowsight to do a lot of this work. I feel Snowflake does a great job at giving you all the puzzle pieces that you need to monitor your account. There's almost 45 different tables inside of the account usage, but maybe we don't necessarily give you the full picture on the box for how to put all these things together. That's the aim of this session today, is to show you how to take these different puzzle pieces that we have, snap them together, and put together something more useful than the individual parts. I need to talk quickly how metering in Snowflake works. Where do you get charged and how can you optimize those spend patterns? And in Snowflake, you only pay for what you use with the elasticity of the cloud powering our solution. So as usage varies over time, that is very different than a fixed cost on a traditional database that has a set number of CPUs. Snowflake CPUs go from 0 to 10,000 to 500 to 0 over the time of day, depending on usage. And so as we use that cloud to enable instant elasticity, there will be points of the day where resources are being consumed versus when they're not. And as those resources are being consumed, we want to make sure they are the right size for the task and the right width for the task. We need to have the appropriate number of lanes on that freeway to handle the traffic volume as that increases. And so as we scale compute up and down, and we go ahead and elastically scale the storage for what you need just by simply using blob, you need to understand that. You need to understand where you're paying for this and how you're paying for this. So there's a few different areas of spend metering in Snowflake. One of the most foremost areas that you have a lot of control over on elasticity patterns, auto-suspend, scale up, scale out, and a per second billing is our compute tier or a virtual warehouse tier. We want to make sure they're on, we want to make sure that they're right size, And we want to make sure we route works to the appropriate sized resources. We're going to give you some more cues on that later on. As well as the storage. We essentially pass through Snowflake's storage pricing to you. We get up to 7x compression by using our FDN format. We have native support, like in the box, right, ready to go for JSON, Avro, Parquet, and other popular data storage formats. We also have our zero copy cloning, our time travel features. We have transient tables, we have regular tables, we have external tables. Understanding how these components are used and understanding what drives some storage cost is very important. And I like to look at objects that haven't been queried in X number of days. Maybe we can purge those. We even do this internally at Snowflake for our own version of Snowflake behind the scenes. It's very important. It's not the biggest portion of your bill, but you still should be good citizens when it comes to looking at data storage. As well as the data transfer pieces. If you have workloads running in different clouds, there may be egress or data transfer fees. Go ahead and take a look at some of your workloads that might be able to be combined within an individual cloud or individual region. And one of the more interesting areas of our metering are the cloud service or the serverless features of Snowflake. There's all these little database components that have been broken out and run on their own sets of resources. And there's percentage billing for certain pieces of these. There's per use billing for certain pieces of these. We want to show how those work as well. When does a search optimization service make sense? A lot of folks are using Snowpipe. We want to optimize some of that. Maybe some auto clustering pieces. Maybe some tables don't need to be clustered because you can do a order by the insert into clause, as well as materialized view maintenance for data changes over time. So let's go ahead and quickly talk about the governance framework that we have inside of Snowflake. We're going to be looking at a few different areas. Visibility. We're going to focus heavily on the visibility today. Control. We're going to focus a little bit on control and resource monitors. There are updates in the product coming soon for resource control groups. And when those things launch, we'll be sure to do new webinars and new videos on those pieces and how you can use those, as well as some tips and tricks around optimization in here. Identify inefficient spend and take action. A lot of queries we're showing you today, we'll be able to do that immediately out of the box. So as we look at visibility, we want to drive understanding to what is going on with usage dashboards, usage data, maybe using Snowsight, maybe just using the out-of-the-box features of Snowflake, as well as object tagging to attribute spend into different groups and business units so you can work with individual bad actors within your Snowflake environment and drive that spend more efficiently, as well as monitor what's going on with resource monitors and alerting. And then as we start to put controls in place, we can have warehouse and size and timeouts limits. We can have auto-suspend, auto-resume, and then resource monitors to even turn things off. In optimization, we're doing work all of the time to improve the platform and run queries faster for everyone. With an optimization, you can look at query profiles and histories and query plans, as well as look at warehouse load and usage history to further optimize the size and width of your resources. Moving on into account usage 101. Now that we understand some of the controls that we have in place for us, let's look at some of the data we have about those controls and things within Snowflake that you can monitor as an admin. The account usage schema is one of my favorite things in Snowflake. And a very simple question is, does Snowflake have logs? Well, yes, we do, but that's internal. We take those logs, we transform them, and we turn those into useful tables and share them with you for every single one of your Snowflake accounts and organizations. There are 47 plus amazing tables in there with very rich metadata about your Snowflake accounts. There's account usage, object billing, object details, logins, session details. And all of that comes as part of Snowflake out of the box with 1 year of full data retention. I find it to be one of the more useful things about Snowflake, and it's ubiquitous. Every Snowflake account has the same account usage schema. So anything that I create and use as part of queries or visualizations, I can share with the community and everyone can benefit from that. I find that fantastic. So what useful objects are in this account usage schema? Well, I can see load history, login history, that looks interesting. File formats, access history, who accessed what, when, and where. Tag history, task history. There's a lot of useful things in here. What do I find the most useful? Well, as I'm working with customers on site, I find access history to be one of the more useful pieces. It has table level access logs along with the columns that were accessed down to the query GUID. That's amazing. As well as the login history for each initial session's login. How did they log in? What type of authentication did they use? Did it fail? These are things I want to know as an admin. And then the piece de resistance, the query history, that has very detailed level query elements that happen within the query ran on Snowflake that you query nerds will love. And I spend a lot of time spelunking that table. As well as sessions, kind of what came in this session, what's in the HTTPS header as that comes in, a very interesting piece of information. As well as the users, who's current, who's been deleted. I want to know who has access to my system. What's the potential risk? Maybe someone got terminated and they still have access. These are things I can answer from there. Along with the warehouse metering history that has hourly level warehouse billing details that can then be joined into things like query history, login history, and sessions to give me a very holistic view of what's going on. Well, enough talk about it. Let's go ahead and jump right in and take a look at some of these queries. I always like to set my database context within each one of my workbooks in Snowflake, and we're working with the new Snowsight UI here. I find it to be quite useful for these types of things. And I'm going to zoom in for you so you have a better time seeing what's going on here. And there's a lot of views, or secure views essentially, within the account usage share. And you can see there's 49 different tables in here. That's a lot. Let's go ahead and take a look at some of the ones I find more useful. Access history. Access history has got some very neat fields in here. Base objects accessed, direct objects accessed. There's some interesting things in here. And as I take a quick look inside of 10 records within my access history, there's going to be some interesting payloads in JSON that will show me all of the columns that were accessed for each one of these queries. And based on who accessed what column, I may be able to find columns that I don't need, columns that don't serve a purpose, that aren't being queried. Maybe I can unload those, right? We can see here that there are a lot of direct objects that were accessed in these columns, right? The query, what happened, what was in each one of these columns. You can see queued repair time, compilation time, inbound data transfer, queued overload time, warehouse type, metadata row ID. This is a stream. Very cool. You can see what's going on with each one of these column accesses. As well as our login history. Login history has got some great information inside of it. I really like seeing the client IP address, the time of the login, the session that was logged in, the password that was used, the client version. What was it? Well, it's the Python driver. Someone's been doing a lot of work on this account with the Python driver. And I even have the username. And not only that, I also have this gem of a object called query history. Query history has so many bits and bobs of data about every single query. The ID GUID, the query text, the database it was ran under, the schema, the query type, right? Unload, select, copy, truncate, the session it was associated to, the user name, the role name, the warehouse it was ran on, the sizing, so many bits and bobs of information, all the way down to the partitions that were scanned in here, the rows that were leveraged for CRUD operations. There is a lot of information that outbound data transfer region. I did an unload. How amazing is that? And then the sessions table. The sessions table has some very interesting things about the application that accessed Snowflake. Here you can see I've got an admin that logged in with their password, their client version, their Python connector. And here I can see, how did I know it was the Python connector? Well, I have this payload that comes in and tells me What was the operating system? What was the application? And lots of different details about that. You can even see logins as simple as the Snowflake web UI. And I also can look at the users that are in my account. The users in my account, were they ever logged in, how their authentication methods are set up, did they ever log in, right? So I can see when they were created, when they were deleted, their login display name, do they need to change their password? Do they have a password, right? I can disable them. I can do all kinds of fun things with them, as well as give them a default context. And I can even see last time they set their password and other bits and bobs about those users. And then of course I can see my warehouse metering details down to the hour. So the start time, end time, the warehouse, the credits that were used on compute and cloud services. So I can then attribute these credits used maybe down to individual queries based on how much time or time percentage they took on the query. Now that we've seen some of the amazing account usage objects within Snowflake, let's look at some of the lowest hanging fruit, some of the easiest queries we can run against these objects to give us an idea about some optimizing of our resources. One of the things I love to check within our warehouses is the auto-suspend policy set. If a warehouse is on and not running any workloads, why should it be on? Right? Make sure you set your warehouses to auto-suspend. By default, these pings are on. And if you do set them to auto-suspend, definitely set them to auto-resume. So the next time a query comes in to the warehouse, it'll automatically come back on in just a few hundred milliseconds. These auto-suspend policies are great. If you have use cases that take advantage of heavy cache usage, like BI use cases, I would leave them on a little bit longer. And for ETL use cases or ELT use cases, when you're done transforming the data, turn that warehouse off. Another thing that's really easy to monitor is maybe a warehouse or a workload that's approaching cloud services billing. This is done for the entire account for a day level, but it'd be good to know workloads that may be approaching this bill back method. And you do get up to 10% of your credit usage for free on this, so it's very few workloads that come in and approach this. And we'll talk more about it as we show the query. We also want to be good citizens, and let's set account level and warehouse level statement timeouts. I've seen people go fairly extreme and give some end user warehouses within BI and analytics 15-minute timeouts. So you can always go in at individual accounts and even individual warehouse levels and set those statement timeouts. As well as purging dormant users, maybe users that haven't logged in ever, or users that haven't logged in within the last 30, 90, 60 days, right? Why should I give them usage to my platform if they are not using it? It just exposes some risk. As well as dropping unused tables. Boy, if I have a table that's out there, maybe in a temp area, I should really be thinking about dropping that. So let's go ahead and move on piece now, as opposed to just talking about theory. So the first thing we're going to look at are warehouses with the auto-suspend. So what I'm doing is I'm running a show command, and then from the last query that I ran here, select star from table, result scan last query ID where auto-suspend is null. This will identify to me warehouses that really haven't been set to auto-suspend, which is a little silly. With a cloud elastic system like this, you really should be having those warehouses set to auto-suspend. The query produced no results. Look at me, I am a good citizen. And let's confirm that result. I'll run this quick show command here, and we'll take a quick little look at the auto-suspend policy. Auto-suspend. Look at that. I looked for null values, and look at this. My minimums are, I got 60s, 300s. This is number of seconds. Let's look at warehouses without an auto-resume policy. Again, I'm running the show command, and then I'm running this quick select star from. These are handy little ways to query against some of the show commands in Snowflake. Again, I'm a good citizen. I haven't done this. So I'm going to look at now the cloud services billing. Do I have any workloads that are running on different warehouses that are approaching this kind of threshold? You can see my report warehouse in August. It looks like that was 100% cloud And then my virtual hands-on lab warehouse, my Salesforce warehouse. You can see these run hardly any queries. We really weren't in danger of the account approaching that. But I can definitely see my task warehouse is doing some activities which use a heavy amount of the show commands. So these kind of start approaching up that threshold, but they're not in danger of hitting those. And if I want to look at if I'm in danger of hitting that amount for my entire account, which is how we're going to bill it, I now can run this same thing by the account. I'm using a quick little CTE, pulling in the cloud services, and I'm pulling in the warehouse metering, and I'm transposing these things against each other. And I can see I was never in danger of approaching that threshold. The closest I got was back in April. I'm also curious about those statement timeouts. Like, what is going on with these statement timeouts? You can see here I've got a value and a default that is set out here for my statement timeout in seconds. And it gives you a quick description of what these are in Snowflake. And I, of course, can alter mine and set it to what I want to. And if I do the show parameters and account again, you'll see I've got all kinds of stuff. And if I just want to see where the value is not the default value, things I have set, you can see I have my budgets database turned on for some testing that I'm doing. And I was looking at an ODBC return type on Arrow versus JSON for some testing I was doing. And again, my statement timeout is set a little bit differently. And you can even do this at the warehouse level, not necessarily the account level. So if I had some warehouses from historically naughty users, let's say, I can throttle them down a little bit by giving them lower statement timeouts. In order to see that piece, I can run the show warehouses command, but as I start looking for that property, you can see I don't really have that property in there. I need to look for parameters in the load warehouse. And as I do that, I now can see some statement timeout set for this. And then for me, I do a lot of showing and demoing, and I want Snowflake to cluster out, so multi-cluster warehouse. So I have my max concurrency level set a little bit lower. Same thing, we can identify some dormant users. Why should you have these users on your system if they have never logged in? So here I'm looking at users that have never really successful logged in, or at least in the last 30 days of creation, right? So I want to make sure they have never logged in and I created them within the last 30 days. This Eldridge guy, why is he not logged in? He must be retiring. And there's a lot of other users on here as I've created things to test menus within Snowflake. Same thing, I can do stale users. What users haven't logged in the last 30 days, last 90 days, last 60 days? I'm going to change this to 90 and try to identify users that haven't logged in the last 90 days. I've got a lot of them, 15. Unused tables. So I can look here now at some unused tables maybe that are inside of Snowflake. These are all of the tables that I have within this database here. And I can look for maybe the last DML that was ran on the object that I'm looking at. So I'm just giving it a full path here. Same thing, I can look to see the number of queries that maybe include this table name in the query text. And I can even maybe set the query text to the table that I'm looking for and look at all queries within the last 90 days. They're executing on my table number foo. So this query here will take a little bit of time to run. We'll go ahead and set the elevator music. All right, none. What a good man. All right, now here I've got set table equal to foo. And if I want to look at this foo table, I'm going to see if anything has been ran within the foo table in the last 90 days. Or maybe it's in a view definition. No, I haven't queried that table in the last 90 days. Same thing here with the view definition. Hasn't been there. I should probably drop table foo. Drop table. This is going to be demo.public.foo. Foo has been dropped, but I don't want to drop that table. I need that for doing some testing that I run periodically. So we're going to go ahead and undrop that table. And I'm just looking at the query text in query history. I think this could be a little bit better if we joined it into the access history JSON I showed you during account usage 101. At some point in the near future, I'm going to write some queries that leverage that. But for now, this is a way to kind of test and look at some of those things. All right, let's talk about some other things we can do within Snowflake to optimize resources. David, I'm really happy so far, but I want less talk and I want more queries. Well, you're in luck. We're running these on Snowflake, and I can't think of a better platform to run queries on than Snowflake. So again, I like to copy objects locally into my own account. Does Snowflake have any logs? No, but we get our account usage objects over 1 year of data retention. This is the one that I kind of cue in on. If I want to have data for longer than a year on access history and sessions and queries, maybe I need it for 7 years based on SOX compliance. This is the one that kind of means the most to me. So I'm going to copy data locally for that. And then I can also look at year-over-year performance and growth of the system as workloads come on and maybe some workloads move off, as well as performance, right? I want to look at these pieces by my own clustering. I want to add in some metadata from HR. I can cluster this better by my own choosing. There's just less micropartitions to invest in when it's not in a kind of shared, secure view. The compile times will go down, and BI and reporting on this should go up. So performance, as well as greater than 1 year of data retention, are some good reasons to copy these things locally. And as I'm looking at this, there's some things that I really like to copy locally. Warehouse metering, query history. If you only do two, do those two. But I also like access history for audit. I like sessions, again, for audit, users for audit, and login history, as well as for compliance and audit. And I'm going to include a bonus query here. As we copy things locally, like warehouse metering and query history, I can use those to kind of allocate percentage of warehouse usage by each individual query over a day or over an hour, and then give that an estimated credit price. And this can be really helpful for telling my admins or even telling myself, where should I go spend time with this customer to optimize a Snowflake workload? Enough talk, more queries. That's what I like. So I'm going to use a database that I call Sandbox with the schema of public, and I use my demo warehouse for doing this work. You can set whatever context you would like, but just note that the Tableau workbook I'm going to include later in this section will be looking for tables within sandbox.public. And I'm kind of curious, what's the date diff for 2022 to today? 213 days. All right. So we're going to set this to 213 days. And now I can look to see what is my date delta. 213 days, just as expected. And I can do some quality control here. Yes, that sets back to the first. And yes, that is 213. Great. Quality control. So I'm going to create a replace table here, warehouse metering, as this selects from start time greater than or equal to that date piece that we just created in here. So let's pull back all of my warehouse metering by each individual hour. And I'm going to cluster by the date or the short date of start time. And I can get a quick little select count star, got about 13,000 records in here. And I can even run a quick test query to see if there's data. Yes, in fact, there is. I'm going to do the same thing for query history. I'm pulling over 200 and some odd days. On your production account, if you've got millions and millions of queries, you might want to think about running this maybe by month, maybe by week, so it runs a little bit faster for you. And you can open multiple sessions and tabs and run the queries in parallel, as opposed to having it run in one big query and taking a bunch of time. This won't take too long for my account. I only run a few 100,000 queries a month. And now I can cluster this. I click the cluster by this query text hash, because I do a lot of grouping and looking of the hash of the query to look to see when like queries have been ran and then hone in on those. I find that to be very useful. We can see that I've ran about 300,000 queries in the last 8 months, which is a lot for an individual with an individual account. I practice what I talk about and I really enjoy it. And now I can see that this query history is in fact working. And now this is an interesting one. This is the estimated job credits. And I'm running a quick little view over top of that, but I like to materialize it. So I'm going to go ahead and materialize this by creating it as a table. So create a replace table, this estimated job credits. If I was testing out materialized tables, this is something I would definitely use for materialized tables as that feature comes closer. And now I can cluster by that SQL text hash and that meter day. And I can make sure this works. Yes, it is working. Great. And I want to make sure that this really closely matches what comes out of warehouse metering. And I can, in fact, see that these things are really, really close when I look at the total estimated credits versus the warehouse metering credits kind of added together. And I've also included a Tableau workbook for visualizing this, which we'll go ahead and look at in the next section.
Now that we've copied over our account usage objects into local storage, let's go ahead and visualize that data. I've included a Tableau workbook for you to start visualizing some of this data, just to point you at the most important queries by using a quadrant. And in this quadrant, I can point to queries that have higher than average execution time and higher than average runs compared to the peer group of queries you're running in your account. So the queries that appear in quadrant number 1, they may be where you want to start. And you can select those and drill into all the times that they were ran by this SQL text hash grouping. And further, you can drill into all of the times that query was ran and gather some insights for how to solve this. So here I've got my Tableau workbook up and running, and you can see I've got my warehouse daily billing. You can see this warehouse here, demo warehouse, June 16th through the 21st. Looks like it spent a lot of credits. I may have turned that on during Summit and never turned it off. I was doing a lot of demos during Snowflake Summit. And now I can see that query dashboard we were looking at earlier, and I can put this in presentation mode to take a quick look at this. And I can see that this is my most expensive query. It's a task running on my task warehouse. Maybe I want to look at this other query here. Again, it seems to be like all ran consistently because I run a task all of the time in my account to kind of self-populate a table to see what's going on. And now I can grab this and drill into every single time that this query was ran and maybe make some inferences about, is my warehouse big enough? Is my warehouse too small? Is my warehouse is not being multi-clustered? Here you can see I had a series of queries where my partitions total and partitions used, it's 3, so an extra small warehouse here seems to make sense for the task. I would also see if there was any spilling over to local disk or any spilling over to blob. I can really see it just took a long time to run these queries execution-wise on 6/16. And I can see all of these queries that took the longest were on 6/16. I think there might have been an overall global Snowflake problem on the 16th of June. I would simply just go check the Snowflake website and get the answer to my question. Not only can I look at the queries and I can look at the daily billing and the running total of billing over time, I can also look at my top 10 queries by spend. So these are all of the SQL hashes, the query count of me running these, and then the estimated credits spent on this query. So I can see that this one query here looks like it's 3% of my overall credit cost. I've spent 7,531 credits so far, and of this, 235 are assigned to just this one task, and I'm spending about 3% of my Snowflake budget on that. I'm curious about this one, number -625. I'm going to drill into that and take a quick little look at what's going on with this particular query. I can also take a look at queries that have spilled to disk, and maybe I want to make sure that those run on a bigger warehouse. I can see this query here looks like it actually spilled a little bit to disk. I'm very curious to see which of those queries that I'm running that have spilled to disk. And now I have the individual query IDs for when they spilled, and now I can go take a look at them. I'm very excited about that. And I can also see credits per job. I can see all kinds of great stuff for queries. I can go start and optimize by visualizing this data. I can see a pattern, and I can take action on that pattern to make my overall use of Snowflake a little more optimized and really make my end users a little happier. Thank you. Now that we saw how to visualize some of this data, we might want to understand how to optimize some of these resources, or what resources to go optimize other than things we're seeing in these visuals. I want to identify deviant performance. And these deviant performance queries here are great because this is going to show me a variance by 7-day window. Is my warehouse spending more or less credits? I actually wrote this query here for a customer that one of their applications had alter warehouse commands and alter warehouse rights. And this application went in, set the warehouse up to 2XL, and left it on all weekend. So they came in on Monday morning to a big bill. If they would have been watching with this deviant performance query, they would have caught that much sooner than when they did. Also, what are my longest running queries? Just simply, what are the longest running queries? I can take those and maybe optimize those or work with those users. And queries that spill to disk and spill to blob notoriously take a little bit longer to run in Snowflake. They don't stop running, that's why we spill, but they'll take a little bit longer to finish for those users. And I maybe want to see access logs so I can look at who's accessing by which app and what query count that they have. These are things you can do in Snowflake that I'm really excited to show you. We can also look at the cache usage in some of our warehouses. Also look, hey, who's doing full table scans? Let's go catch those people and tell them, hey, no more full table scans. And also, I want to give you serverless cost visibility to your automatic clustering, your materialized view refreshes, your search optimization, your snow pipes, and your replication costs. But enough talking about it. Let's go in and run some SQL. I'm going to look at unusual performance maybe over the last 30 days here. And I'll be able to look at these by warehouse and kind of figure out what of my warehouses here are using more credits than before. You can see my load warehouse here is up 40%. My demo warehouse today is up 106%. I've been doing a lot of things and showing my screen a lot the last couple of days here at Snowflake for our valued customers. So I do expect those things to be up. And I can even chart this if I want to. I'm gonna go ahead and look at a line chart here. And we don't care about warehouse name count. Oh no, we look at that variance to 7-day average over date, and we can further add a column here, maybe by warehouse name. And now I can see very plainly that on my demo warehouse went way up on August 9th. It went way up on August 11th. It went up quite well, there on August 2nd. So yeah, I'm spiky with that demo warehouse. You can see days I'm demoing and days I'm not, as well as cloud services seem to be increasing. I've been doing a lot of testing of some of the cloud services over the last few days, so very expected. Very, very expected. Also, what are my longest running queries? If I run this here for my longest running queries, I'll now very quickly know what are my top 25 longest running queries. Here they are. Call store procedure unload, create or replace table sandbox. Also my spillers here. I'm gonna look at my date delta for 90 days. I wanna look at my top 25 spillers here. Who is spilling over? Let's go ahead and take a quick look. Oh, actually nothing spilled. I've been pretty good about not spilling anything. Same thing when I spilled a blob. I don't think I'm gonna see anything here. I write really good queries, I think, so I'm not spilling a lot. I'm using appropriately sized warehouses. Again, nothing spilling over here. And maybe I want to see what's in my table access logs. This is great. So I'm going to take my table access logs, my query history, and my sessions. I'm going to put all of these things together to make sense of it. And what's really kind of interesting about this sessions table is it has a little payload of client application ID. So I can see who's coming in with what application. And so I can use this to group access by those applications. So I'm gonna look over the last 45 days or so, and I'm gonna look at, in here I got access history over the last 45 days, and I'm gonna be able to pull the actual tables that were accessed for every single one of my queries. Not only the table,
but I can also pull the column IDs. Look at these columns in here in the table that it was pulled from. And so now what I can do is I can really kind of take that direct objects access JSON payload, and I can pull out all the tables that are being accessed by my queries. And now I can combine that together, split some things out, and now I'll be able to tell you in the last 45 days what tables in my system have in fact been accessed, just like that. And I can tell you the table type and the table name, etc. Right? These tables here, they've all been accessed in the last 45 days. And I can put this all together and aggregate it. I can grab the queries. I can grab the access logs and the table names. I can grab the sessions and applications. Then I can tell you by user, by application, by table, what things are getting accessed the most. You see the Snowflake web app here over the last 45 days has done 45 queries against this Johns Hopkins University COVID-19 table. Query history, if out of a Snowflake account usage, warehouse metering history. See, I use these things on an almost daily basis. I was doing an external table demo. Right now I can see I've done 13 accesses of this external table that I've been showing in the last couple of days. It's really up to date and accurate. I can also see what warehouses are using cache. So I got the number of queries on each warehouse, the byte scan, bytes from cache, and the bytes cache percentage. I can see my task warehouse uses a lot of cache. My demo warehouse, where I'm showing the same thing over and over and over again, uses quite a bit of cache, 37%. But my load warehouse, where I'm really playing around and doing a lot of ETL and data engineering weirdness, is only at 18%. Very much expected. And this query here is for all you DBAs that want to find those folks doing full table scans. Look at these queries by the admin. He is doing full table scans here, 16,000, 17,000 micropartitions. Going to also look at my automatic clustering cost by day over time. So I can very quickly see here which days am I doing the most credit spent on my automatic clustering, as well as my materialized view cost by day. And I can look at my search optimization costs. I don't have many tables enrolled in search optimization. I don't think this is going to say anything, yeah. And Snowpipe, what are my Snowpipe costs? Well, I use this quite often when I'm demoing streaming. Like I want to be able to show people streaming by day, what's going on. And now I can see, yes, I have in fact been spending a little bit of money on Snowpipe by day. Same thing if I have replication costs, I can very quickly access those. And there's more fields than what I'm showing you here, but I'm just showing you how to very quickly access these things. So now we've seen some different optimizations, different things we can look out for, and ways of accessing our serverless costs. Now that we've seen all the way we can optimize queries and warehouses to look out for, how can I be alerted of things that need to be optimized right away? How can I put cost controls in place so I don't even have to be alerted about that? Well, we have an object class in Snowflake called a resource monitor. And that resource monitor can have thresholds and things set to alert and warn, alert and suspend based on different budgets that you set up for different Snowflake accounts and different Snowflake warehouses. And so we can quickly identify warehouses that don't have any resource monitors. We'll show you how to do that. Also, we'll show you how to apply resource monitors so you can create quotas for individual warehouses to limit spend and get alerted when you get to these areas, as well as how to set budgets. And this is a new feature in private preview in Snowflake that I'm really excited about, where we can establish resource groups of different tables and warehouses and serverless features and give those things a budget. Because my retail group operates on different warehouses and tables, and my operations group here is operating in a couple of different databases, as well as having serverless features. So I can put these resource groups together and then monitor budgets at something higher than an account or a warehouse. This is a great little feature that's coming. Also, serverless cost controls. With these resource groups, we can put serverless spend in and give that budget as well. Very excited about these. And if you're watching these after it has been released, I am hoping that you're finding the same value I am out of these pieces. Enough talking about it. Let's go ahead and see the SQL. So I switch over here to the SQL. We're gonna be looking at a few different things. I'm gonna be looking at resource monitors on my warehouses. So I'm gonna do a show warehouses command. And now I'm gonna find warehouses without resource monitors. You can see I'm pretty naughty. I don't have very many resource monitors on my queries. But if I wanted to create one, like this Kurt Loves Cubes resource monitor, I can create that resource monitor with a credit code of 150, and I can apply that. So I can alter warehouse apply. So all these things that I'm doing here in SQL, you can also do in the UI. I choose to do it over SQL just because I want to be able to very quickly apply that, and I want to be able to apply that across many different dashboards and many different warehouses and resources. But it's real quick to do in the UI as well. If I come over here into my admin piece and I look at my warehouses, I can see my different warehouses. I can grab my ad hoc warehouse and then very quickly come down in here. I can see privileges, I can see details about it, I can see warehouse activity, and I can come into my piece here. I can edit this warehouse. As I edit this warehouse, I will be able to change its size, etc. But if I want to apply that resource monitor, I go to my resource monitors. I can add different resource monitors here. If I want to apply them to the actual warehouse themselves, I'm going to be doing that over SQL as opposed to in the new UI. Pretty sure that'll make its way in there shortly. Thank you so much for sticking with us this far. We've shown you a lovely Tableau visualization on some of these things that we're looking at. But David, what about Snowsight? Well, I want to show you something I've been working on for a while with various different customers, all the things I've been learning over the last several years that have put into a Snowsight concept. And this dashboard's quite big. There's about 17, 18 different queries that I've included in the accompanying SQL file. I'm not going to walk you through each one of these things, but the PDF that'll be linked here as well has how I've laid out each one of these things to get what I'm looking for as we're working with this. And so enough talk about it. Let's show you this live in action. So as I come over here, I can see I've got this lovely CTE, which compares a previous 6-day period with the following period before that, so week over week, essentially. So I'm looking at number of queries, this period versus the previous period I put in here. You can change these windows if you wanted to, and then of course you can chart that. I don't want a line chart, instead I'm gonna do this scorecard chart. So I've got my previous number and I could add in here number of queries and see I'm down from the previous period. I'd probably do it the opposite way. I'd do number of queries and then do previous, and then I can see I'm up 12%, which makes a lot of sense. I've been running a few more queries this week. But I want to show you a little bit more on the dashboard itself. If I come here to the dashboard of this query history concept, last 7 days versus previous 7 days. Again, I can see my queries, my credits, my average duration, gigabytes scanned is up, rows are way up, gigabytes spilled to disk is up for the first time in a long time, spilled to S3 is down, 15 full table scans, I've been naughty, different query areas that I've been performing when I'm writing a lot of live queries, my warehouse load percentage, my credits per day, and then my number of users. I also really like to look at kind of queries by warehouse. So I can see the current period I've done more work on this load warehouse, but less work on the task warehouse. Credits by warehouse is pretty much lockstep with queries. But what I looking at is warehouse efficiency. Credits per query by warehouse. I can see my demo warehouse is far worse than my load warehouse when it comes to per query efficiency. Maybe that's something I should look into. My last 7-day variance, man, my demo has been way up. But again, I've just been showing my account more these last couple of days. My slowest queries that were ran more than 5 times. Maybe this is something I should go take a look at. And then kind of the queries that have lapsed in by scatter by warehouse. So I'm looking at number of credits by the total duration. These resources here are a little more efficient, and these ones here are a little less efficient. And then queries by warehouse over time. So just a number of queries I'm running in each warehouse. You see my load warehouse has done a lot more these last couple of days. than previously. And then my top 50 queries over time. I can go get information about each one of those, get the query IDs, maybe go look up them in the UI to make sense of those. So it's a great little concept, a good way to get started, showing you how to do comparison with piece over piece. There's a few CTEs that join a lot of stuff together, but you can put this together at your own pace. I'm not going to walk you through how to put together a Snowsight dashboard, but all of the pieces you need to put it together and all the SQL are contained within these files. And there's some useful ones in there. And now that we're at this point, I've given you a lot of information to go take and use and apply to your accounts and alter and modify and make anything for any of your Snowflake accounts. What's great about this content is because account usage is a universal schema shared with every Snowflake account. Anything that you make is usable by other people using Snowflake. So join us in the community. Let us know what you've created. Send me an email, show me what you've done. I'm very excited to see this. And if it's fantastic, I'd love to take it in and make it part of my own work and share this with more people, even on my blog. So we've shown you how to fit puzzle pieces together. You've got a part of the picture. It's time for you to go off and build and fill out the rest of this. And so I just really want to call attention to some additional cost governance courses at Snowflake University. There's this new course that's available starting on the 27th of June, so that is available for you now. And then, anything else further, there's these billing metrics, performance on quick starts, there's setup and configuration, usage monitoring on quick starts. It's a great place to go. If you want to follow me, you can look at my blog, Big Data Dave, or go over to my GitHub, Big Data Dave as well. I'm constantly putting content out in those areas. And mostly, I want to thank you for taking time out of your day to make your Snowflake cost performance better, and better for your organization and better for your users. I find the community that does this to be small, but very potent. Have a great day and happy querying.
Thank you so much for watching our video on Snowflake resource and cost optimizations today. If you have any additional questions, please reach out to us on the Snowflake forums. If you really enjoyed this video, please go ahead and give it a like, as well as subscribe to the channel to get further notifications when we publish additional content.